Hello and welcome back to Apex Grace. Today we dive into an important topic in index numbers, that's splicing. Have you ever come across a situation where two sets of index numbers have different base years, making comparison difficult? That's exactly where splicing comes in. In this video, I will explain what splicing is, why we use it, and walk you through a step-by-step example. So what's splicing? Splicing is a statistical technique used to combine two separate index number series, typically one old and one new, into a single continuous series. This situation arises when an existing index series based on an older base year is discontinued and a new series is introduced using a more recent base year. Because these two series are based on different base years, they are not directly comparable. So what this is trying to say is, can I have an old index number, assuming it's based on year 2002 to maybe 2015. Then from 2015, with the same item, continue from 2015 to maybe 2024. So because the old was based on 2002 and the new was based on 2015, you can't directly compare them, or they are not comparable. So there is the need for us to bring them to a single base so that we can easily compare. To make meaningful comparisons, it becomes necessary to convert these two series into one continuous series using a common base. This process of linking or merging index numbers of different base years is what we refer to as splicing. Now, splicing is only applicable when the following conditions are met. So the first one is both the old and index series are constructed using the same set of items. You can't do for, let's say, an item of population and an item of inflation. No. If they are both population or employment, they should be the same throughout. The second point is the two series have different base years as indicated here, 2002 and 2015. So we have different base years. Then there is at least one overlapping year or link year between the two series. That there should be a common year between the two series. Now we have types of splicing. There are two main types of splicing based on which series is adjusted. So you have the backward splicing and the forward splicing. Backward splicing is used when the new index series is adjusted to match the base year of the old series. It allows the newer data to continue from the older series, maintaining historical continuity. So what this basically means is that for backward splicing, we are bringing back the new index numbers we've constructed based on the new base year back to match the old index number. So assuming this example I gave here, that we have the old index number to be 2002 and the new one to be 2015. So if you are bringing the values here, that's from 2015 upwards, back to match the 2002 base year, then we are conducting a backward splicing. How do we convert this new series back to the old one? Is the index number to be spliced times the old index at the link year or at the overlapping year, all divided by 100. Then for the forward splicing, when the old index series is adjusted to match the base year of the new series, then the method is called the forward splicing. This updates the data to align with the scale of the newer series. Likewise, if we are bringing the old index numbers to match the new index numbers, then it is called the forward. We are bringing it forward. We are bringing the old to match the forward. It's also given by the index number to be spliced divided by the old index at the link year or at the overlapping year times 100. Let's take an illustration. So basically the splicing is just what? To bring the two index numbers to a common base for the purpose of comparison. Two series of price index numbers are given below. Splice them on the old base, that's 2006, and also on the new base 2012. All right, how do we go about this? You could see that the old base, this is the old base and this is the new one. Why is it the old? It's old because it is being constructed using 2006 and this one is the new one, which is 2012. And you can see that there is an overlapping year here, which we call the link year, is year 2012. Why is it overlapping? Because for the old, we discontinued the old series, that series A, at this particular year, and we continued a new one, which is series B, the same year. So that's the link here. That is the link here. Now, how do we convert or send the new series to fill the old series here? How do we do that? So meaning that if we are bringing the new series to match the old series, that's A, we are conducting what? A backward splicing. A backward splicing. So if you want to convert this series B back to match the series A, as in to fill the gaps here, then it is a backward splicing. So now let's do that. So the first one, we are going to start with the backward splicing. And the backward splicing is given by index number to be spliced times old index number at the link here, all divided by 100. So for the first one, that's year 2013, we have to what? Splice the 125. So for year 2013, index number to be spliced is the 125 times old index at link year. So now this is the link year. Year 2012 is the link year. And we have the old and new. We are saying old. So the old is what? 185. all divided by 100. Well, 505 times 185 divided by 100 is giving us 231.25. Then for 2014, you can say that index number to be placed is 140 times old index at link here, all divided by 100. So we could see that the multiplying factor is 185 over 100, 185 over 100, 185 over 100. We throw out. So 140 times 185 divided by 100, 259. Then for 2015, index number to be placed, that's 155. 155 times old index at link here divided by 100. $286.75. For 2016, we also have 175. 175 times 185 divided by 100. 323.75. 323.75. So now we can also go ahead to construct the series A. So assuming you have series A here, so we have the year starting from 28, 2008, 2009, 2010, 11, 12, 2013, 2014, 15 and 16. Now we have the index numbers based on, as the base was base 26 as given. Yeah, so the first one was 130, 130, 145, and for the second one, 161, 169, 161, 169, 185, 185. Then when it comes to 2013, because we converted the new ones to the old one, we got 231.25. 231.25. Then for 2014, 259. 2015, 286. 286.75. And 2016, 323. 323.75. So now we have our continuous series for series A. All right. Now let's come back to the question. So we are done with everything here by converting the new one to the old series. That's a backward splicing. Now, if we want to fill the spaces here, what do? We need to what? Align the series A, which is the old one, to match the what? The new base, which is year 2012. So there is a need for us to convert the old index numbers to the new index numbers. And we're doing that. We are also conducting a forward splicing. Forward splicing. So let's solve it here. So we have forward splicing. Also, forward splicing is given by index number to be spliced divided by old index at link year or the overlapping year times 100. Okay, so now we are going to what? Place the first one is 130. So let's place the 130. Let's place the 130. So for 2008, we have index number to be placed, that's 130. Then old index at link year, 185 times 100. 130 divided by 185 times 100 is giving us 70.27. Then for 2009, we need to place the figure. That's 145. 145 divided by 185 times 100. 78.38. Then 2010. 161. 161. 185 times 100. 161 divided by 181. 185 times 100. 87.03. Then 2011, 169 divided by 185 times 100. 91.35. So now we are done. 91.35. So now you can construct a continuous series for the series B. So we are going to have something like this. Also the year. Also have the index number. Now this one is series B. '28. 12, 8. So here is 10, 11, 12. We have 13, 2014, 2015, and 2016. So for 2008, we had a figure of 70.27. 70.27. For 2009, 78.38. 78.38. 2010, 87.03. 87.03. 11 was 91.35. 91.35. Okay, when you go to 2012 too, we have 100. Also have 125 and 140. 125 and 140. Then 155. 155 and 175. 175. All right. So now let's solve another question. A statistical agency compiled two separate index number series for a group of consumer goods. The index numbers are as follows. So we have here from 2010 to 2015, and the old series with the base of year 2010 and new series with the base of year 2012. So we are required to fill this space here and this one here too. How do we go about it? How do we go about it? Also, one may ask that, you see, the previous example, we only had one overlapping year, but here we have two overlapping years. That's 2012 and 2013. Do we see that? So how do you go about it? So if you have such scenarios, it's best we go or we choose the first year. We are going to choose the first year to be the link year. So here, for instance, because 2012 was the link year, as in was the year we switched to another base year, it's best we use 2012 as our overlapping year. Also, because the earliest overlapping year, it is also what preferred. It is also preferred. So whenever you have more than one overlapping year, check which one comes first for the purpose of consistency and for to correct any distortion in our data. We go in for the first year. So now let's convert or match the new series to fill in the gaps here to match the old series. So if you are doing that, then we are doing a backward splicing. So for year 2014, 14. Index number to be spliced, which is 115 times old index at link here. Old index at link here. So our link here is what? Year 2012, and the old is 120 divided by 100. 115 times 120 divided by 100. 138. Therefore, 2015 125 times 120 divided by 100. 125 times 120 divided by 100. 150. So here basically you have 138 and 150. Let's go ahead to find the figures here and this. So here too, we are converting the old series to match the new series. When we do that too, we are also undertaking a forward splicing. And for forward splicing is given by the index number to be spliced. So in this case, we are dealing with year 2010. So index number to be spliced is 100 divided by old index at link here. So the same 120 times 100. $83.33. So for here, you're going to get 83.33. Then for year 2011, index number to be spliced is 110 divided by old index at link here times 100. So I have 91. It's equal to 91.67. 91.67.